Welcome to Yatim Khana and Madrasa, Anjuman Khairul Islam's Pune College of Art, Science and Commerce, Camp Pune 1. Myself, Dr. Arif Tamboli, working as Associate Professor in the Department of Electronic Science. Students, today we are going to cover the topic which is called as reverse bias characteristics of PN junction diode, which is also called as current versus voltage characteristics. And one more topic which we are going to cover because it is related to the very much basics of 10th standard and 12th standard. Why diode does not obeys Ohm's law? Ohm's law you are studying from almost 8th standard, or let us consider 10th standard. So why diode does not obeys Ohm's law? So this is another topic we are going to study. So our main target will be the reverse bias characteristics of PN junction diode. In the last lecture or previous lecture, we have studied forward bias characteristics of PN junction diode, and I am going to show you the simple diagram for the forward bias characteristics and simplified circuit diagram for the forward bias characteristics which we have already studied, that is as shown below. So in this diagram what we have done here, see. So circuit diagram for forward bias characteristics of PN junction diode. This is not today's topic, but I am showing you the simplified circuit diagram. Only what we have done here, this battery we have shown as a variable battery. This battery we have shown as a variable battery, and the voltage of this battery is varying from 0 volt to 10 volt. From 0 volt to 10 volt. Earlier this battery was not there, and there was a battery of constant 10 volt. There was a battery of constant 10 volt which was connected to variable resistor, which was connected to variable resistor, and that battery of constant 10 volt or fixed 10 volt along with variable resistor was working as variable power supply, so that power supply along with fixed 10 volt battery and variable resistor you can replace over here somewhat like that, and this is your variable voltage. VR stands for variable voltage, plus of the voltmeter to plus of the battery, minus of the voltmeter to the minus of battery. So whenever you change this voltage of the battery from 0 to 10 volt, then this voltage is measured by this voltmeter VR, and this is your variable voltage source which we have replaced. I will show you the diagrams here. Here there is a fixed 10 volt battery V in, and here there is a resistor which is variable resistor, 3 terminal, upper terminal, lower terminal, and variable resistor which is called wiper, and this is your voltmeter VR. Now here it is a reverse bias characteristics, that's why this voltmeter's polarity are changed. But in forward bias characteristics, upper terminal of voltmeter was positive only and lower was negative. So here this much portion we have replaced by the variable battery. And now let us proceed forward. Reverse bias characteristics of PN junction diode. So all of we know that, so in reverse bias condition, the PN junction diode does not conducts. But let us start for that to understand the concepts. As shown below, the diode is connected in reverse direction. As shown below, the diode is connected in reverse direction, and the variable voltage source, that is VR, which we have already used in forward bias condition also, and here also we are using in reverse bias condition also. The variable voltage source VR is change in reverse direction from from 0 volt to minus 10 volt. So variable voltage source we have just changed it in the reverse direction, or is applied in the reverse direction, you can say that. So here circuit diagram for reverse bias characteristics of PN junction diode. So here this voltage is constant again plus 10 volt, but now here see, very important, here what we have done here, the diode is connected in reverse direction. So this statement is important. As shown below, the diode is connected in reverse direction. Our variable voltage is same, plus minus fixed 10 volt battery. Then this variable resistor is there, 3 terminal, upper terminal to the positive of battery, lower terminal to the negative of battery, and wiper of the variable resistor or variable terminal is connected to the, here now you see, the diode is reversed, is connected to the cathode of the diode, is connected to the cathode of the diode, and anode of the diode gets connected to the negative of battery through the load resistor RL, and anode of the diode gets connected to the negative of the battery through the load resistor RL, and therefore now here it is said that this diode is reverse biased. This diode is reverse bias, and in this statement that is only we have mentioned, as shown below, the diode is connected in reverse direction and variable voltage source is applied, and variable voltage source is applied in reverse direction to the diode, because anode of the diode gets connected to the negative of the battery, because we have reversed the direction of the diode, we have reversed the direction of the diode. Therefore anode of the diode gets connected to the negative of the battery, of course through load resistor RL, and cathode of the diodes, here this is the cathode terminal, vertical line. This cathode of the diode gets directly connected through variable resistor to the positive of battery, through variable resistors to the positive of battery. And as I mentioned in previous lecture, all current meters are having internal resistance 0. All current meters are having internal resistance 0 if you're talking about ideal current meter. Otherwise, for practical current meter, the resistance is in few ohm. Resistance is in few ohm. Now here, very important things to be observed here. This voltmeter, you look at this voltmeter. This voltmeter is connected such that negative of voltmeter is to the variable terminal. Negative of voltmeter is to variable terminal, because this voltmeter we want to be measured. This voltmeter should measure the voltage in minus, should measure the voltage in minus. Therefore negative of voltmeter is connected to variable terminal, and then it goes to the positive of battery, then it goes to the positive of battery through variable resistor. And look at the positive terminal of the voltmeter. The positive terminal of the voltmeter is connected to the negative terminal of the battery. The positive terminal of voltmeter is connected to the negative terminal of the battery. Now in the next diagram, which is simplified, we are removing this variable voltage source. We are removing this variable voltage source. So as I already told you, what do we mean by a variable voltage source? Variable voltage source is a combination of fixed voltage source and variable resistor. Fixed voltage source and variable resistor. Now, the measurement of voltage, whether it should be positive or negative, it depends on you. Therefore, here you want to measure the voltage as a negative. Therefore, you connected negative of this voltmeter to the variable terminal, which is going to the positive of the battery, and you connected positive of voltmeter to the negative of battery, and therefore here this VR is variable voltage. VR is the variable voltage which will be measured in minus. When you change this wiper up and down direction, this voltage is going to change at this point, and this will be minus. Now look at this microammeter. This is not a milliampere, because this is microampere, because our diode is reverse bias. Our diode is reverse bias. Again, I will explain you why the diode is reverse bias, because we have changed the direction of the diode. In forward bias condition, see the diagram over here only, the diode's anode was going to the positive of battery and cathode was going to the negative of battery. Anode on the left hand side, cathode on the right hand side. In reverse bias direction, what we are doing, we are changing the direction of the diode. Therefore anode of the diode gets connected to the negative of the battery through resistor RL, and cathode of the diode, see here cathode of the diode gets directly connected through current meter to the variable terminal, gets directly connected through current meter to the variable terminal, and variable terminal is going to the positive of battery. Therefore in short, cathode is connected to the positive of battery, and that's why this PN junction diode is reverse bias. So when the PN junction diode is reverse bias, you know that width of depletion layer increases and current does not flows in case of ideal PN junction diode. But in case of practical PN junction diode, small amount of current in microampere. Small amount of current in microampere will flow, and that current is called leakage current. Therefore, this current meter is microampere. Therefore, this current meter is microampere. And again, look at the polarity of the current meter. The current flowing, the current flowing through the PN junction diode is in what direction? In reverse direction from cathode to anode. See here the direction of current. Here the direction of current is in this direction, positive to negative from the current meter. That is, here it is a cathode to anode because diode is reverse biased. So current flows in the reverse direction, that is from cathode to anode, but that current is very less. It is in microampere. If unfortunately if you connect this current meter milliampere, if unfortunately if you connect this current milliampere, then the current meter will never show any deflection. The current meter will never show any deflection because in case of reverse bias of PN junction diode, the current is very less in microampere, and the sensitivity of milliampere is less as compared to sensitivity of microampere meter. So therefore be careful that you must use microampere only when you are studying reverse bias characteristics of PN junction diode. One more thing I will mention you again. Always we connect the voltmeter across PN junction diode. Always we connect voltmeter across PN junction diode, and we always connect the voltmeter such that positive of voltmeter to the anode of the diode and negative of voltmeter to the cathode of diode. Therefore now this voltmeter will measure the voltage across diode in reverse direction, that is in negative, in reverse direction, that is in negative, because again we see it's very simple. The voltmeters positive, which is connected to the anode of the diode, the voltmeters positive which is connected to the anode of the diode is also connected through the load resistance to the negative of this battery. To the negative of this battery means positive of voltmeter goes to negative of voltmeter. And look at the negative of voltmeter. The negative of voltmeter which is connected to the cathode terminal of the diode gets connected through current meter and through variable resistor to the positive of battery. So in this way, negative of voltmeter is connected to the positive of battery. Of course, through current meter's internal resistance is very less in few ohm, and then through this resistor to the positive of battery. Therefore, this voltmeter will also measure voltage across diode as minus, that is negative, and current is already flowing in negative direction from cathode to anode. Current is already flowing in negative direction from cathode to anode, and therefore the IV characteristics means current versus voltage characteristics of PN junction diode in reverse bias condition will be in third quadrant, and whatever this I explained you here just 5 minutes before, that entire thing is explained in detail in the next slides. So here we know that in reverse bias condition, diode does not conduct for all applied voltages, for all applied input voltages from 0 volt to minus 10 volt. For all applied input voltages from 0 volt to minus 10 volt, the PN junction diode does not conduct. But small amount of current, here there is should be a small s, but small amount of current which is called leakage current, which is called leakage current passes through the diode or flows through the diode. This graph of reverse bias is in third quadrant because voltage across diode is measured in minus Vd, and current flowing through the diode both are negative. Therefore the diode characteristics of the reverse bias will be in third quadrant. And here again we are going to measure three parameters like in forward bias condition. Which three parameters we are going to measure? See here, we are going to measure applied input voltage Vin to the diode in reverse condition with the help of voltmeter Vr. Here it is a reverse voltage. we are going to measure the applied input voltage V in, which we are applying in reverse direction because cathode is connected to positive and anode is connected to negative, and this voltmeter is connected in reverse direction. Upper terminal is minus, lower terminal is plus. So this applied voltage, which is reverse, which we are going to measure in one column. Secondly, we are going to measure the microampere current in microampere, how much current it is flowing. And of course, that current is reverse current. See here, cathode to anode. The direction of current is cathode to anode. So second parameter in the second column which you are going to measure is your reverse current in microampere. And third parameter which we always measure is the voltage across diode, that is VD. Voltage across diode, that is VD. And this in this way we are going to measure all these three parameters for various reverse voltage applied as input. For various reverse voltage applied as input, and you'll observe that this voltmeter is connected in negative direction, this voltmeter is connected in negative direction, current meter will also show the current in what minus only because this is reverse current. So all these three parameters which we are going to measure for different input voltage which is we are applying in reverse direction. So in that is the what you called study of reverse bias characteristics of PN junction diode. Now let us proceed to the simple diagram now. See here. So this is your called reverse bias characteristics. So diode is reverse. Diode is reverse. Anode of the diode is over here. Cathode of the diode is over here. It is by mistake here it is written here. This is not a cathode. So please try to understand that anode of the diode is here, which is going to what? Anode of the diode is going to become anode of the diode is connected to the negative of battery, cathode of the diode is connected to the positive of battery, and see this battery we have replaced now. This battery we have replaced now with the help of variable battery, with the help of variable battery. And this variable battery is changing from 0 volt to 10 volt, 0 volt to 10 volt, but positive of battery is connected, see here, to the cathode of the diode through current meter. Internal resistance of current meter is very less. Therefore, you can directly consider that this terminal is connected directly to the cathode. So here in this diagram, positive of the battery is connected to the cathode of the diode and negative of the battery is connected to the anode of the diode, and negative of the battery is connected to the anode of the diode. And here, this is very important, this voltage source which is variable is from 0 to 10 volt. Why it is 0 to 10 volt varying, and why it is replaced? Because earlier here we have used variable resistor over here which was converting a fixed 10 volt 0 to 10 volt into 0 to minus 10 volt. So here it is a reverse bias in the we are measuring the voltage in reverse direction, that's why measured is in minus. So in this entire part, fixed voltage source and variable resistor we have now replaced with the help of variable battery, but battery changing from 0 volt to 10 volt. Now we are measuring the voltage across battery in reverse direction by connecting this voltmeter such that minus negative of voltmeter to the positive of battery and positive of voltmeter to the negative of battery. So when this voltage is 1 volt, the measured voltage by this voltmeter will be minus 1 volt. The measured voltage by this voltmeter will be minus 1 volt because voltmeter is connected in reverse direction. But important part is what? Diode is reverse bias. How does? Cathode of the diode is connected to positive of battery and anode of the diode is connected to negative of battery. Current meter is shown over here such that positive of current meter is to the positive of battery and negative of current meter is going through connected diode and this thing to like this here to the negative of battery. And always voltmeter which is connected across diode, voltmeter which is connected across diode such that positive of voltmeter to the anode of the diode, you please forget this cathode. So positive of voltmeter is to anode of the diode and negative of voltmeter is to the cathode of the diode. So in this way, this is again a simplified diagram. And sometimes what happens? Sometimes the diagram is shown in a very different manner. The diagram is shown in a very different manner because this battery is having plus terminal upper side, minus terminal lower side. So sometime this battery is only reverse. Battery is only reverse. And in that case, if you reverse the battery, you need not to reverse the diode. You need not to reverse the diode. So anode of the diode should get connected to the positive of battery, sorry, negative of battery, and cathode of the diode should get connected to positive of battery. That is called reverse bias characteristics. So here sometime this battery is reverse. Upper side is minus, lower side is plus. In that case, the diode should not be reversed. In that case, left hand side will be the anode of the diode and right hand side will be the cathode of the diode, because anode will be connected to negative of battery if the battery is reversed. And that diagram again I am going to show you. So here, see, now we have not reversed the diode. This is the anode of the diode and this is the cathode of the diode. So anode of the diode is on left hand side, cathode of the diode is on right hand side. And again I am repeating, voltmeter is always connected such that positive of voltmeter is to the anode of the diode, negative of voltmeter is to the cathode of the diode. Now how does the diode get reverse bias? So look at the left hand side. On the left hand side, the battery is now shown as 0 to minus 10 volt. The battery is now shown as 0 to minus 10 volt because upper terminal of the battery is minus and lower terminal of the battery is plus. That's why the battery is marked as a 0 to minus 10. And voltmeter, look at here, voltmeter is connected such that positive of voltmeter to the negative of battery and negative of voltmeter to the positive of battery. Means this case is only reverse as compared to previous case. Previously we are saying 0 to 10 volt because upper terminal is plus, lower is minus, and we are connecting voltmeter in reverse direction, minus of the voltmeter, negative of voltmeter to positive, positive to negative. And now here what we are doing, here only we are changing the polarity of the battery. Upper is plus, lower is minus, upper is minus, lower is plus. Therefore we are saying it is 0 to minus 10. And while connecting voltmeter, we connect in reverse direction because we are going to study what? Reverse bias characteristics. This is a very simple thing. And one more change is here. See, current meter is connected such that current meter is connected in series to the diode only, because whatever current flowing through the diode that we want to measure, current meter is connected such that negative of current meter to the negative of battery, negative of current meter to the negative of battery. And remember, this current meter measures reverse current. See the direction of current, reverse current flowing from cathode to anode of the diode, because diode is reverse biased. This current meter measures reverse current flowing from cathode to anode of the diode. Actually speaking, for an ideal diode, no reverse current should flow. Reverse current should be zero flowing from cathode to anode. But due to minority charge carriers in p type as well as in n type material, small amount of reverse current flows, that is called leakage current. Small amount of reverse current flows, that is called leakage current. So I have explained you all three diagrams. You can use this logic, minus upper side plus lower side, but measured reverse voltage should be minus. That's why voltmeter's positive should come to negative of battery, negative should come to the positive of battery. But don't forget that voltage across diode, whenever you are measuring, the voltmeter connected in parallel to the diode must have positive to the anode and negative to the cathode. Thereafter, you decide whether you want to forward bias the diode or you want to reverse bias the diode. If you want to reverse bias, anode must be connected to the negative of battery and cathode must be connected to the positive of battery. This way, or in previous case, we have reversed the diode only. Here, we have reversed the diode and we have kept the battery same, upper side plus, lower side minus. But to measure the voltage negative, these terminals are reversed and anode of the diode here is connected to negative of battery and cathode vertical terminal is a cathode of the diode which is connected to positive of battery. Or here I'll go in this diagram conventional, a fixed voltage source converted into a variable voltage source, and you are measuring this voltage in reverse direction with the help of this voltmeter. You are measuring this voltage in reverse direction with the help of this voltmeter such that minus to the variable terminal and plus to the negative of battery. And rest things are very simple. And then what we'll do, we'll study the what reverse bias characteristics. Reverse bias characteristics of PN junction diode, which is also called current versus voltage characteristics. For a practical diode, I am going to explain you first. So look at the diagram very carefully. As I told you, this graph is in first, second, and third quadrant. This graph is in third quadrant. Why? Because when you are going to study the reverse bias characteristics, the voltage applied to the diode is reverse, means minus, and therefore current flowing through the diode is also minus. That is ID. ID means diode current. So this diode current is flowing from cathode to anode, that is reverse current. Cathode to anode, that is reverse current. So it is a minus ID. So now look at the diagram very carefully. The graph is in third quadrant, that you understood why it is there. Now second important part, when you increase the reverse voltage, because see here, this is the center point, 0 is here. Positive voltage will be on this side, plus 1, plus 2, plus 3, plus 4. Negative voltage will be on the left hand side. So minus 1, minus 2, minus 3, minus 4, like that. So in this way, when you go on increasing the reverse voltage, you observe that here there is a small gap. See this red line. Can you see this red line? And there is a black x-axis. So this black x-axis and this red line, in between that there is a small gap, and this small gap is nothing but what here, see, on y-axis. There is a reverse current minus id. On y-axis there is a reverse current minus id. So here above the x-axis, on y-axis there is a positive current, and below the x-axis on y-axis there is a minus current. So this current is called leakage current. So in this way, small amount of leakage current starts flowing, and again you observe very carefully, the leakage current goes on increasing as reverse voltage minus 1, minus 5, minus 10, minus 20. As reverse voltage increases, the leakage current goes on increasing. And in case of practical diode, these characteristics of what? Practical diode. In case of practical diode, at very high reverse voltage, for example, minus 50 volt, that is called breakdown, means breakdown will occur. VBR means PN junction diode will damage. So at very high voltage, say minus 50 volt, negative voltage, breakdown occurs and PN junction gets break. Therefore, normal PN junction diode, which is used for rectifying purpose, there is a limit how much reverse voltage you should apply. And that reverse voltage is also called as peak inverse voltage. PIV. And maximum reverse voltage, how much you should apply so that the diode should not get damaged, it is given by the manufacturer. And this understanding is also very simple. In reverse bias condition, or in reverse bias case of practical PN junction diode, the graph is in third quadrant. As you go on increasing the reverse voltage, the leakage current goes on increasing, and at very high reverse voltage, say minus 50 volt, the breakdown occurs. Now here, as shown in above, the current meter is microammeter. That is what I explained you in the beginning diagram. The current meter is microampere, and diode is connected in reverse direction such that anode of the diode is connected to the negative of battery and cathode of the diode is connected to the positive of battery through the variable resistor. So this is our first example case of what? Here, reverse bias. Anode of the diode is connected to the negative of the battery. Anode of the diode is connected to the negative of battery through RL, and cathode of the diode, see vertical line, it is a cathode. Cathode of the diode is connected through current meter and through variable resistor to the positive of battery, and this meter is microampere current meter. So here that description is given over here. As shown above, the current meter, that is microampere, and diode is connected in reverse direction, such that anode of diode is connected to negative of battery and cathode of diode is connected to the positive of battery. Now next part is explanation only. When reverse voltage VR is applied to the diode starting from 0 to minus 10 volt, 0 to minus 10 volt, at that time current will not flow through the diode. At that time current will not flow through the diode, because as applied reverse voltage increases, the width of depletion layer also increases and diode behaves as open switch. And diode behaves as open switch. This explanation is about ideal diode. This explanation is about ideal diode, because applied reverse voltage as increases, the width of depletion layer also increases and diode behaves as perfect open switch in case of ideal diode. And but practical diode is, there is something that is written over here, see. But due to minority charge carriers in each type semiconductor material, due to minority charge carriers, minority, not majority. All of you know that in n-type semiconductor material, electrons are majority charge carrier. In p-type semiconductor material, holes are majority charge carriers. So here, but due to few minority charge carriers in each type, that is p-type and n-type, in each type, that is p-type and n-type material, in each type, p-type and n-type material, some amount of leakage current flows through the diode. So some amount of leakage current flows through the diode. So as shown above, at very high reverse voltage, approximately minus 50 volt, the breakdown takes place and diode is damaged. So as shown above, at very high reverse voltage, say minus 50 volt, the breakdown occurs. The breakdown occurs and diode gets damaged. And in this way here, the diode is normally not operated. Which diode? Rectifying diode. So here rectifying diode is normally not operated in reverse bias condition at very high reverse voltage. At very high reverse voltage, it is operated in reverse bias condition up to certain reverse voltage, up to certain reverse voltage, to avoid the damaging, to avoid the damaging. Now let us go to the reverse bias characteristics of ideal PN junction diode. Reverse bias characteristics of ideal PN junction diode, and reverse bias characteristics is also called as current versus voltage characteristics. So for ideal PN junction diode, so look at here on the left hand side, third quadrant. So in the third quadrant, ideal PN junction diode, what it indicates, a red line indicates an arrow is marked. Ideally, no current flows for all reverse voltages. Ideally, no current flows for all reverse voltages. Whatever reverse voltage you apply, minus 1 volt, minus 10 volt, minus 20 volt, no reverse current flows. Reverse current is zero. And that is ideally. Practically what happens? Practically small amount of leakage current flows. Practically small amount of leakage current flows. And this leakage current goes on increasing as reverse voltage increases, goes on increasing. See here, the reverse current goes on increasing at minus 40 volt. The reverse current is very large. But of course, remember, this current is in microampere. This current is in microampere. So even though if you say reverse current is large, it is in microampere. Micro means 10 raised to minus 6. Micro means 10 raised to minus 6. So this is the difference between ideal diode and practical diode. Ideal concept is imaginary concept which does not exist in real life, and there is a practical diode always. So this is the ideal condition. Apply any amount of reverse voltage, minus VD, minus 1, minus 2, minus 20, minus 30, no current should flow. And here we have shown both the things. The third quadrant reverse characteristics, first quadrant forward characteristics. So in forward characteristics, ideally, this is again ideal, up to 0.7 volts here, up to 0.7 volt, zero current flows. Positive current ID is what? Zero. Exactly at 0.7 volt, the current starts flowing. So this is both characteristics, ideal and ideal characteristics in forward bias and in reverse bias, it is shown over here. So in this way here, as shown above, in ideal case, reverse current, that is minus ID, flowing through diode is almost zero for all applied reverse voltages. For all applied reverse voltages. And now here, this is the measurement of what? Reverse voltage minus VR, voltage across diode minus VD, and current flowing through diode. So this observation is in case of ideal diode. Why? Because when you apply the reverse voltage minus 1 volt, minus 2 volt, minus 3 volt, and like that minus 10 volt, the voltage across diode will be same, because diode behaves as open switch, and all of you know by this time that if the switch is open, then that switch, whatever voltage you apply to that switch, the voltage measured across switch will be the same, because that switch is open and it is not short circuiting the applied input voltage. Therefore, in case of reverse bias characteristics, the diode behaves as very high resistance device in mega ohm, in mega ohm. Therefore, whatever reverse voltage you apply to the diode, VR is the reverse voltage applied by you to the diode minus VR, minus 1 to minus 10. The measured voltage across diode, that is again same, minus 1, minus 2, minus 10. But the current flowing through the diode is 0. But the current flowing through the diode is 0. And this is the observation for ideal PN junction diode. In case of practical PN junction diode, when you perform the experiment at low reverse voltages, say up to minus 5 volt, zero current will be shown. But at high reverse voltage from minus 6, minus 7, few microampere current will be flow. Few microampere means 5 microampere, 7 microampere, 8 microampere, and it will be less than 20 microampere only. So it is a very less current in microampere. Micro means 10 raised to minus 6 ampere. And in this way here, this diagram is you can say observation table is also very simple. Applied reverse voltage, of course you are applying voltage in reverse direction to the diode, that's why that is in minus. So once again I am going to show you that here. See, it is in minus because 0 to minus 10 volt, you are measuring the voltage applied to the diode in reverse direction, because anode of the diode is connected to the negative of battery and cathode of the diode is connected to the positive of the battery. Therefore, this voltage will be minus VR. The measured voltage across diode will be again minus, because positive of this voltmeter is connected to negative of battery and negative of this voltmeter is connected to positive of battery. Therefore, these two things are minus and your current flowing is 0, which you have shown. But if you write the current, that current will be in negative only, because that is a reverse current flowing from cathode to anode. Flowing from cathode to anode, or in other language you say conventional direction of flow of current is what? From positive to negative. Conventional direction of flow of current is from positive to negative. And in earlier case what we have done here, like that, positive to negative, but diode is reverse. That's why that current is also a reverse current. So in this way here, the observation table is taken for ideal diode and like that. And one more graph I am going to show you now, and that graph is called as what? Graph of forward bias as well as reverse bias characteristics in one graph only. But here it is shown ideal as well as practical. Look at this blue line. If you look at this blue line, actually this is the zero point 0.7 volt. This is the zero point 0.7 volt, but the current starts flowing before zero point 0.7 volt. Current starts flowing before zero point 0.7 volt. And what should be the ideal? So this should be the ideal. This should be the ideal. Now look at this reverse characteristics. This is the leakage current. This is a small current, which is what? Leakage current, shown by the two arrows. And here, ideally there should not be current. So this is the axis. Ideally there should not be current. This is the on the same axis. And at very high reverse voltage, breakdown will happen. Diode will get damaged. So reverse bias characteristics are in third quadrant. Forward bias characteristics are in first quadrant. And with this, what we'll do it, we'll conclude that our forward bias condition characteristics and reverse bias characteristics are over. Now here, this is a very simple concept. Anode of the diode is connected to negative of battery. Cathode of the diode is connected to positive battery and it is shown as open switch. So it is considered that the diode is open switch. As shown above, the reverse bias PN junction diode offers very high resistance in mega ohm. Therefore, it is shown as good as open switch. It is shown as good as open switch. But actually speaking, in reverse bias condition for practical diode, small amount of current in microampere flows. Therefore, it cannot be replaced by a perfect open switch. It cannot be replaced by a perfect open switch, but due to very high resistance mega ohm, we consider it as a equivalent. We consider it as a equivalent. And with this, what we'll do it here, we'll conclude that the reverse bias characteristics and working of a PN junction diode under reverse bias condition you have understood in detail. And in the next lecture, what we'll do, we'll go for the topic which is not possible to cover now: why fixed value resistor obeys Ohm's law, and why PN junction diode does not obey Ohm's law. Why PN junction diode does not obey Ohm's law. Why PN junction diode does not obey Ohm's law. That we'll see in the next lecture, because that topic is again a little bit lengthy one. And here again one shot, let me cover that basics again. Whenever you forward bias the PN junction diode by connecting anode to the positive of battery and cathode to the negative of battery, and whenever this voltage is greater than barrier potential, whenever this applied voltage is greater than barrier potential, the diode starts conducting, and voltage across PN junction diode is zero point 0.7 volt only. And voltage across PN junction diode is zero point 0.7 volt only. Again, I will repeat here. This voltmeter is also connected directly in parallel to the battery, such that positive of battery to the positive of voltmeter, negative of voltmeter to the negative of battery. Even though the battery is of 10 volt and voltmeter is directly in parallel to the battery, voltmeter is not measuring 10 volt, because PN junction diode is responsible for that. This PN junction diode, when it started conducting after 0.7 volt, this PN junction diode, when it started conducting after 0.7 volt, at that time, this PN junction diode short circuits the voltage of this battery over and above zero point 0.7 volt. This PN junction diode short circuit the voltage of the battery over and above zero point 0.7 volt, means 9.3 volt of the voltage of this battery is short circuited by this PN junction diode, and that is also called as drop across this PN junction diode. Therefore, measured voltage is equal to 0.7 volt only. And one more diagram here, see, plus 10 volt battery, left hand side plus, right hand side minus, voltmeter is directly connected to the battery, but this voltmeter is measuring how much volt? 0.7 volt only, even though it is directly connected to the positive of the battery and negative of battery, because above the battery there is a diode, because above the battery there is a diode, such that anode of the diode is to positive of 10 volt battery, cathode of the diode is to negative of 10 volt battery, and this diode is playing the role. Why? This voltmeter is not in a position to measure 10 volt, it is measuring 0.7 volt, because this diode has short circuited the voltage above zero point 0.7 volt of this battery. Means after 0.7 volt, when diode started conducting, after 0.7 volt when diode started conducting, the voltage over and above zero point 0.7 volt of battery gets short circuited by this diode, and short circuit voltage is always equal to 0 volt, that all of you know very well. And therefore, whenever this diode is there, the diagram looks like that. Why this voltmeter, even though it is directly connected to the battery, not measuring 10 volt? The reason is what? The diode is in parallel to the voltmeter as well as battery, and it is in forward direction. But if you reverse the diode, try to understand, if you reverse the diode, no doubt this voltmeter will measure 10 volt. Simply reverse the diode, don't change the polarities. Simply reverse the diode, cathode to the positive of battery and anode to the negative of battery. Diode is behaving as open switch, and then voltmeter will measure 10 volt. Then voltmeter will measure 10 volt, and here that is what diagram we have shown horizontally. Simply reverse the diode. Anode of the diode is to the negative of battery, cathode of the diode to the positive of battery. Diode is equal to open switch, yes. Diode is equal to open switch, yes. And here this diode is behaving as an open switch. Therefore, now see here, this voltmeter is connected. Positive of voltmeter is to positive of battery, negative of voltmeter is to negative of battery, and now this voltmeter is in a position to measure this voltage as a 10 volt, because now diode is not conducting. Now diode is not conducting. But again remember, if you reverse this diode such that anode upper side, cathode lower side, then this current will not be zero, current will be maximum. Current will be maximum, and voltage measured by the diode, sorry, voltage measured by the voltmeter will be zero point 0.7 volt only. And this is very important concept in electronic science: measurement of voltage across the diode when it is forward biased and reverse biased. Now if you change the polarity of this voltmeter, upper side minus and lower side plus, if you change the polarity of this voltmeter, upper side minus and lower side plus, the measured voltage will be minus 10 volt. Because what you are doing, simply you are connecting voltmeters negative to the positive of battery and positive to the negative of battery, and the switch is open, means in between this voltmeter and battery there is open switch which is nothing but the reverse bias diode, then that will be minus 10 volt. And I hope this is very simple, because I have explained you everything. Now the diodes looks like this in the market. If you purchase the strip of the diode for 1 rupee, you will get one diode, or for 75 paisa you will get one diode, and like that here it is like this. So thank you very much for watching this video, and in the next lecture we are going to study why PN junction diode does not obey Ohm's law. So in this way here, thank you very much.